वेलकम टू ऑल। आज हम स्टार्ट करने वाले जो नया टॉपिक है लेज़र एंड होलोग्राफी का। ठीक है, हमने पिछला टॉपिक कंप्लीट किया था डिफ्रैक्शन पोलराइजेशन। ठीक है, तो आज हम लेज़र एंड होलोग्राफी पे हैं। सबसे पहला क्वेश्चन हमारे पास है, एक्सप्लेन अंडर व्हाट कंडीशन स्टिमुलेटेड एमिशन ऑफ रेडिएशन कैन टेक प्लेस इन लेज़र, डिस्कस ब्रीफली हाउ होलोग्राम्स आर मेड यूजिंग लेज़र। तो सबसे पहले स्टिमुलेटेड एमिशन के बारे में हम देखते हैं। सपोज टू लेवल्स E1 एंड E2 इन एन एटम. If an electron goes to level E2 by absorbing a photon H.mu, when the atom is in excited state E2, a photon H.mu is also incident. This incident photon can also cause de-excitation, that is, it may cause an atom in upper level to drop down to lower level. ठीक है, this follows from the principle of detailed balance, which is stated as at equilibrium the total number of particles leaving a certain quantum state per unit time is equal to the number arriving in the state per unit time. That thus, if a photon can stimulate an atom from lower level to an upper level, then photon with equal probability should also be able to stimulate an atom from upper level to lower level. So in this case, atom have from excited state E2 to E1 by emitting the photon H.mu. Right, तो ये E1 से E2 में आता है, तो H.mu stimulated emission. The addition photon has some energy as that of incident photon to conserve energy and will be in phase with the incident photon to conserve momentum. This process is called stimulated emission and is of interest in lasers. Now, construction of holograms. The object is illuminated by highly coherent and monochromatic light, which, such as laser beam, each point on the object reflects or scatters light to the entire photographic plate. We know that the scattered wavefront from a point from spherical and concentric around the point of origin, but an object is supposed to be made of such a number of points, so the resultant wave pattern reflected from the surface of the objects can be taken as sum of many such as of spherical waves, each set concentric about its point of origin. It is called reflective object wave. When this object wave is superimposed on a reference wave obtained from the same source of light of illuminating object, and the interference pattern so formed is recorded on a transparent photographic plate, it is called hologram. ठीक है, इस डायग्राम में भी आपको बताया हुआ है, that is called hologram. The hologram does not contain a distinct image of the object. It consists of highly irregular fringes having no apparent relationship with the object, but this hologram or this interference pattern contains all the information about the intensity and phases of scattered waves from the object as shown in this figure. ठीक है, explain the term inversion of population and stimulated emission as applied to lasers. Population inversion and stimulated emission. To have laser action, we must have more photons emitted than absorbed. Therefore, we must have a situation in which stimulated emission dominates. Thus, establishment of a situation in which the number of atoms in the higher energy level greater than in the lower energy level is called population inversion. Pumping. The procedure adopted to achieve population inversion is called pumping. In optical pumping, the active material is illuminated with the light suitable frequency E2 minus E1 upon n. As a result, an atom in lower energy state E1 absorbs the incident photon and n is raised to the higher energy level E2 and spontaneous emission takes place, but this method fails to produce necessary population inversion. In actual practice, population inversion is brought by a three-level scheme. Right, what is that three level? The atom is excited from E1 to E3 by the process of stimulated absorption. ठीक है, some excited atom quickly drop to intermediate energy level E2 by spontaneous emission and thereby converting their excess energy into vibration kinetic energy of the atoms. E2 is metastable state, energy state having mean life more than 10 to the power minus 3 seconds as compared to E3. Thus in this time the population of state E2 is more than that of E1. The resulting in population inversion of collection of atoms in state E2 at atom decays by spontaneous emission or stimulated emission. In this way laser beam is produced. Now what is the basic principle of holography? The word holography originates from the Greek word holos, meaning holes, hole, and a graphy meaning writing. That is, holography means complete recording. In holography, the image of the object to be photographed is not recorded by the light waves reflected from the object or are recorded. The photographic record is called hologram. The basic principle of holography is as follows. When a beam of coherent light is scattered from an object allowed to overlap on obstructed coherent beam, interference fringes are produced on a photographic plate placed in front of object. In 6.A figure, a point object A is embedded in a monochromatic plane wave incident from left. The scattered wavefronts are spherical with center at a point object. Right. Now the last thing is that the scattered wavefront are categorized by their amplitudes and phases. The scattered or diffracted light from object A superpose over coherent incident light and produces a hologram on the photographic plate PQ placed to the right of A. Due to constructive and destructive interference between diffracted light and direct reference beam, the pattern is bright and dark concentric circles on a photographic plate. In case of three-dimensional solid B, the solid may be regarded as a collection of a number of points. Each point diffracts its own set of spherical wave. The resultant wave pattern diffracted from the entire solid is very complex. Now the interference between diffracted wavefront and reference beam modifies intensity at all points. Then the modification in intensity is in accordance with phase relationship between the waves at all points. In this way, the phase variation in the wave pattern diffracted from the object are converted into intensity variation. The interference pattern is formed on the photographic plate. When the photographic plate or hologram is illuminated by laser light, the object is reconstructed. So this is completed. Okay. Now the next topic is fiber optics. So we will see the questions on fiber optics now. First question on fiber optics: explain the construction of optical fiber, describe the propagation of light through it. तो optical fiber का construction क्या? The term optical fiber is not for textile but as light guides. They act as a carrier of light signals. Optical fibers are made of transparent glass, polymer or dielectric through which light can pass. Optical fibers act as a carrier of electromagnetic energy at optical wavelength. Optical fibers are used in modern optical communication. Okay. Now construction of optical fiber. A typical optical fiber is shown in the figure 9, this one. It consists of a core glass silica plastic with appropriate diameter of 10 to 100 micrometer with refractive index mu. Okay. The core is surrounded by a glass or a plastic cladding with refractive index mu2, which is less than mu1. The difference between delta mu is mu1 minus mu2 is very small, of the order 10 to the power minus 3. The refractive indices mu1 and mu2 may be of the order of 1.52 and 1.48 respectively for a common optical fiber. Okay. The third one, for providing safety strength, a buffer plastic coating known as jacket. For glass optical fiber, the diameter of the core ranges between 10 to 600 microns. The cladding thickness is between 123.630 microns, and that of jackets varies from 250 to 1014 microns. The main difference between glass and optical fibers is their diameter, which makes POF easier to handle. The phenomenon on which optical fiber works, light travel and remains confined to optical fibers due to phenomenon of total internal reflection. The phenomenon which is responsible for brilliance of diamonds and other precious stones, mirage, looming, etc. Total internal reflection is the phenomenon of returning of light in same denser medium when light is incident in denser medium greater than critical angle. That is the angle of incidence in denser medium for which angle of refraction is rarer medium is 90 degree, right? Now from Snell's law we can say that mu2 upon mu1 equals to sin I upon r, sin incident or reflection. So now IC equals to sin inverse mu2 by mu1. For I is greater than IC, there would be no refracted ray and all the light will be totally internally reflected. Transmission of light by optical fiber. Consider the optical fiber in which the light enters the core of optical fiber in figure 11 like this. In case light enters at an angle smaller than critical angle, that is among the path OQ, it will get refracted at I on the interference for a core and cladding. The refracted ray would go to the boundary surface of cladding, but if the angle of incidence is slightly greater than the critical angle, say light travels along PO, it will be reflected along OA and rather it will be remain confined within the core due to successive total internal reflections at the interface, separating the core and cladding, and will finally emerge out fiber from the other end. The light can travel a large distance in the core whether the fiber is straight or folded, because the fibers are so made that angles of incident of light travels in wire in the guided manner, right? And hence optical fiber is sometimes called optical waveguide. The maximum angle of incidence in air for which all the incident light is totally reflected at the interface of pair of media having refractive indices mu1 and mu2 in the given relation, that sin I equals to under root mu1 square minus mu2 square. The value of maximum angle of incidence is known as acceptance angle. ठीक है, so next video में हम आगे पढ़ेंगे. Thank you very much.